Well, hello everyone. We are going to move on to our next section on week eight's work. In fact, this is the last section. There's a lot more going on here, as you can see from this list. So let's get started with the first topic, which is exponential and logarithmic form. Before I get into the details of what that is, I want to give you a kind of background. Imagine I wanted to give you some information about the connection between a calculation and its answer. I could tell you that 5 squared is 25. And that is definitely true. 5 squared is 25. And I could tell you that then that the connection between 5 and 25 is that 5 squared is 25. And we might call this the square form. So it's basically telling us how the two numbers 5 and 25 can be connected. And the connection is there's a square thing going on. Of course, I could have taken that same information and said that the square root of 25 is 5, which is true. Only now I would call this the square root form. So this idea that you can rewrite some information connecting two numbers in this case in two different ways is kind of key to what exponential and logarithmic form looks like. So let me show you some information that's written in its exponential form. 3 to the power of 4 is 81. That's its exponential form. 5 to the power of 2 is 25. 7 to the power of 3, I wish I hadn't picked that one now, is 49. 49 is like 50. 50 times 7 is 350. Knock off 7. 343. Pick an easy one now. 10 to the power of 6 is a million. These are all examples of exponential form. We're now going to introduce you to a calculation that you do in a number called its log. Let's take this piece of information. And we're going to call this the exponential form. What we're going to do is we're going to introduce this calculation called a log to base something of a number. And the log to base 3 of 81 is 4. We'll call this the logarithmic form. So if someone asks you to find the log of a number, they're really trying to say to you, what power of the base would give you 81? So what power of 3 would give you 81? 3 to the power of 4 would give you 81. So what power of 5 would get you 25? Well, the log to base 5 right, of 25 would get you 2. What power of 5 gets you 25? Now, if you look at this, there's actually a little pattern going on how I can take exponential form and convert it into its logarithmic form. We start at the base, so it's 7. And then we go to here. So that's of 343. And what does that equal? It equals 3. So log to the base 7 of 343 is 3. In other words, what power of 7 would get you 343? 7 to the power of 3. That's the guy. So this fella is the log to base 10 of 1,000,000 6. And I call this the circle of life. It's just a made up name, but I like it, so I'll use it. You can do any calculation using this kind of circle of life movement. So let's put in, I don't know, 4 to the power of 3 is 64. Now I want to find out what the logarithmic version of that would be. So I'd start off with log to the base 4 of 64 equals 3. And that's the exponential form. This is the logarithmic form. Of course, they aren't always going to be numbers. You could get x to the power of 4 equals 12. Now that would be log to the base x of 12 equals 4. Right? Start with the base of that number, gives you the power. You can even do it with nothing but variables. A to the power of b equals c would get you, in its logarithmic form, the log to the base a of c equals b. So what we've been doing here is that you've been given information that's written in its exponential form, and we've been converting it into its logarithmic form. Let's try it the other way around. Suppose I give you some information in its logarithmic form. So suppose I say to the log to the base 2 of 64 is equal to 6, which you'll have to trust me right now is true. That is its logarithmic form. Well, I would like to turn this into exponential form. Start at the base. Let's do that circle of life thing. Of 6 to the power of 6 equals 64. Suppose I went and said to you, log to the base 10 of 1,000 is 3. That's what I gave you. And I said, write that information in its exponential form. You start with the base 10 to the power of 3 equals 1,000, which is obviously true. You can even have variables. The log to base 7 of x is 2. Well, start with 7 to the power of 2 equals x. So 7 power of 2 equals x. So we now have a way of taking information that's written in its exponential form and converting it into its logarithmic, information in its logarithmic form, and now converting it into its exponential form. And that's a skill building exercise, because what we're doing is we're eventually going to use that to evaluate logs. So let's see how that can be done. I'd like to know what the log to the base 2 of 16 is. I'd like to know its value. Well, what you do is you call it x. So I'm trying to find out what x is, right? It's equal to the log to the base 2 of 16. Well, I can't really do much with that because I'm kind of stuck. So let's change it into 2 to the power of x equals 16, which is its exponential form. And then you should be able to, with a little trial and error, figure out what x is. Well, 2 to the power of 3 is 8, so 2 to the power of 4, there you go. X is 4, which means we now know that the log to the base 2 of 16 is equal to 4. Well, that one's pretty straightforward. Let's make it a bit harder. Log to the base 8 2. Well, I'll make that x. And now that becomes 8 to the power of x equals 2. And what makes that hard is that it's not a whole number now. You can tell that's not going to work. 8 to the power of 1, 8 to the power of 2, 8 to the power of 3, you're not going to get 2. The fact that it is quite small tells me then that I'm going to have to do a square root or a cube root. Well, if I do a little trial and error, the square root of 8 is definitely not 2. But the cube root of 8 is 2. And the cube root of 8 is a third. So that tells me that x is a third. And so the log to the base 8 of 2 is a third. That's a bit sneaky. Let's try some with negatives. The log to base 5 of 1 over 125. I'd like to find out what the value of that is. Well, we'll call it x. And then we're going to go 5 to the power of x is 1 over 125. And what we have to do here is figure out how to rewrite 125 in terms of 5 to the power of something. Well, it's 5 cubed. And then you can say, well, that's the same as 5 to the negative 3. And now you've got your missing x. So the log to the base 5 of 1 over 125 is in fact negative 3. So you can use the changing of an exponential to a logarithmic form to help you evaluate the value of a log. Of course, it's quite limited in its scope because there's only so many things that you can deal with and get nice answers like that. Most of the time, you're going to have to deal with values that aren't whole numbers or negative 3s or a half, right? You're going to deal with just 8 decimal places or infinite decimal places questions. So that leads us on to our next phase, which is trying to find my list, my number 3. I'm sure it's how do you find logs using your calculator? So that's where we're kind of looking at right now. Just see if I can find my piece of paper to keep this thing going. And I know where it is now. It's down here. So, using your calculator to evaluate logs. Well, let's show you how you can do that. Oh, before I do that, I've got a little notation issue. Log to the base 10 of whatever the number happens to be, let's say it's 1,000. The convention is if it's log to the base 10, you just don't write the 10. Now you could get log to the base e of, 7. Well, the convention is you don't write log to the base e. You write ln instead. It means the same thing. So log to base 10 or log to the base 10 of any number at least is going to be log of that number. So if you see that, you know it means the same as that. If you see this, it means the same as that. If you're wondering why ln, it's the natural log. Like the natural exponent is e, e cubed. The natural log is log to base e. I believe it's from the French, which is log du naturel. So that's where that comes from. So I'd like to be able to calculate, let's put in some others. Log to the base 10 of 7. Log to the base e of 1,000. So basically, I'm going to try and find out, for instance, in this question here, what power of 10 would get me 7, and what power of e would get me 1,000. So this thing is going to be called log 7, and this guy is going to be ln of 1,000. And since we're doing it on the calculator, give me a few moments to load it up. Here we go. Now, down on the left-hand side, you should see log. That's log to base 10, and ln, log to base e. I want to find the log to base 10 of 1,000. Now, that one's a nice number. I already know what the answer is. What power of 10 would get you 1,000? And the answer is 3. And it is, as we predicted. Now, what about log to the base e of 7? Well, ln 7. Let's hit enter. That will not be a nice number. In fact, that'll be one of those infinite decimals, but non-repeating. So it's 1.9459 and a whole load of other stuff, which I'm not going to write down. Now, the next one is log to base 10 of 7. So what power of 10 would get you 7? Well, you really couldn't guess that. Take forever. Let's see what horrible decimal it is. 0.84 and some stuff. And 0.8451 to 4 decimal places. And lastly, log to the base e of 1,000. And that happens to be a pretty ugly answer as well. It's approximately 6.9078 if you round it off to 4 decimal places. So let's just have a look at these guys. Have you noticed that the log to base e of 7 and the log to base 10 of 7 are nothing like each other? And that the log of 1,000 and ln of 1,000 are nothing like each other either? And it's not a surprise because 4 to the power of 3 is not the same thing as 2 to the power of 3, right? So the logs would not match anyway. So that's great, but I would like to get log to the base of other bases, not just base 10 and base e. I would like to know, is it possible to find the log to the base 23 of 101? Well, yes, it is possible. But if you went to your calculator and the TI-84, it's there, it can be found, but it's quite difficult to find how to get the log to base 23 or any other base because it's well hidden. And so I suggest what we do instead is that we use a thing called the change in base formula to help us. So I'll come back to that guy. Let me show you the change in base formula. If you want to find the log to the base a of some number b, you can find it by finding the log of b over the log of a. And there's two versions of the change in base formula. This one uses base 10, and it's the natural log of b over the natural log of a. So to get the log to base 23 of 101, I would find the log of 101 and divide it by the log of 23. That should be interesting. Let's do it on the calculator. So the log of 101 divided by the log of 23. And the answer is approximately 1.8702 to 4 decimal places. Now, I could have done the ln of 101 divided by the ln of 23, and the ln of 101 is not the same number as log 101, and the ln of 23 is not the same number as log of 23. Yet when you divide these two different numbers, I will still get that as my answer. So let's show you. ln 101 divided by the ln of 23. Isn't this remarkable? And I screwed up. Oh, I screwed up here. So let's do this as a lesson. Do you notice what I did wrong here? Because the correct answer is not 0.1872. Now have a quick look before I show you what I did wrong. Do you notice that I didn't put a bracket here? So let's do it again, correctly this time. The log of 101 divided by the log of 23. And now we should get 1.417. And we did. That's easy, isn't it? Well, easy for me, as I'm getting old. To just, not hit a button that you should have hit. So we can essentially find the log to any base that you could possibly imagine of any number. So I'm just going to write this guy down for a few seconds. 1.4719, roughly. So suppose I wanted to find the log to base 5 of 82.1. Right, the log to base 5 of 82.1. Well, I could just do the log of 82.1 divided by the log of 5. And that would be my answer. So the change in base formula essentially allows us to use our TI-84 calculator to find the value of any log you could possibly want. Right? Log to base 23 of a number like 101. Let's check some of these. Let's check this one, that the log to base C of 7 is actually that number. Now what I'm saying here is, I'll write it down here just so it's easy to notice it. 1.9459. Now I've rounded that off, so it goes on forever. What's that telling me is that e to the power of 1.9459 is the power of e that you would need to get 7. Let's do a check on it. So according to what I've got, e to the power of 1.9459 should be pretty close to 7. And you might say, well, it's a little bit out. Yeah, it's a little bit out because it wasn't 1.9459. It was 1.9459, forever. And the bits that I didn't use is why we're, about 5 decimal places out. But I think that's pretty convincing that we now have a way of finding logs to whatever accuracy we want. If they are log to base 10 or log to base e, then you've got a button on your calculator. If they're any other, use the change in base formula. Either one will do, they both give you the same result. And that is us for this lesson.